Hello, I'm Jayshree Kumar, and today I'll be presenting for the course of Software Architecture and Design Patterns. So the pattern that I'll be presenting on is the bridge pattern, and the things that I'll be presenting on include the intent, motivation, the structure of the pattern, the consequences of the pattern, the known uses, and also my demo application that will be demonstrating how the bridge pattern works. So firstly, the intent of the bridge pattern is basically a structural design pattern that lets you split a large class or a set of closely related classes into two separate hierarchies, abstraction and implementation, which can be developed independently of each other. Next, the motivation of the bridge pattern is basically to separate a varying entity from a varying behavior. In simpler terms, it's to separate an abstraction from its implementation so that these issues can vary independently. Sometimes we say it in this way. It is to separate what something is from what it does, where both of these things vary for different reasons. So next, this is the structure of the bridge pattern. So as we can see, the client does not want to deal with the platform-dependent details. The bridge pattern is what encapsulates this complexity behind an abstraction wrapper. The bridge emphasizes identifying and decoupling interface abstraction from implementation abstraction. Next, the participants of the bridge pattern include abstraction, refined abstraction, implementer, and concrete implementer. So what the abstraction does is it defines the abstraction's interface and maintains a reference to an object of type implementer. Then the refined abstraction extends the interface defined by abstraction. The implementer, on the other hand, defines the interface for implementation classes, and this interface does not have to correspond exactly to abstraction's interface. In fact, the two interfaces can be quite different. So typically, the implementer interface provides only primitive operations, and abstraction defines higher level operations based on these primitives. Finally, the concrete implementer implements the implementer interface and defines its concrete implementation. So these are like the four participants of the bridge pattern. Now we look at the consequences of the bridge pattern. So there are three main consequences. Firstly, the bridge pattern, causes decoupling of the interface and implementation. So an implementation is not bound permanently to an interface. The implementation of an abstraction can be configured at runtime. It's even possible for an object to change its implementation at runtime. Decoupling abstraction and implementer also eliminates compile time dependencies on the implementation. Changing an implementation class doesn't require recompiling the abstraction class and its clients. This property is essential when you must ensure binary compatibility between different versions of a class library. Furthermore, this decoupling encourages layering that can lead to a better structured system. The high-level part of a system only has to know about abstraction and implementer. Next, the second consequence of the bridge pattern is that you would have improved extensibility. This is because you can extend the abstraction and implementer hierarchies independently. Last but not least, using the bridge pattern, you can hide implementation details from clients. So you can shield clients from implementation details like the sharing of implementer objects and the accompanying reference count mechanism, if any. Next, let us look at the known uses of the bridge pattern. So when do we exactly use bridge pattern? We use the bridge pattern when we want to run runtime binding of the implementation. Next, we also use it when we have a proliferation of classes resulting from a coupled interface and numerous implementations. Next, We also want to share an implementation among multiple objects, so we would have to use the bridge pattern here. And last but not least, we would use the bridge pattern when we need to map orthogonal classes hierarchies. So a very simple example of the use of bridge pattern would be in a household switch controlling light, ceiling fans, etc., etc. So the purpose of the switch is to turn a device on or off, and as you can see in the very simple class diagram, the switch is connected to the switch implementation and makes use of the bridge pattern to do the process of controlling the switches for the lights and the ceiling fans and whatever other switches that are there. So next, this is my demo application. Um, it is an application for the building of device and remote system. So the remote is used to control the volume and the channel of the devices. So this application illustrates how the bridge pattern can help divide the monolithic code of an app that manages devices and their remote controls. The device classes act as the implementation, whereas the remotes act as the abstraction. And this is the class diagram for it. As you can see, the remote class has all um, the methods: toggle power, volume down, channel up, and then the device class also has all of those functions, as well as get volume, get channel, set channel, enable, disable, and so on. And then radio and TV classes inherit from the device class. And the advanced remote class, that is to set the device to mute, and that inherits from the remote class. So this is my source code for the application. As you can see, the remote control class has all the methods set up for it, and then we have the advanced remote control that inherits from remote control, and then we also have the device class, and then we have the TV class and the radio class that inherit from the device class. And basically all of the methods are pretty much similar, because all we do in this demo program is to set the channel and set the volume like according to what the client needs. And so this is the output for my demo application. So as you can see, it's working, and like what I did was I just wanted to check for the TV and the radio. So for the TV, I increased the volume from 10 to 20. So I just increased it once. And then for the channel, also I increased it once from 5 to 6. And then for the radio, I tested to decrease the volume and the channel. So I decreased once the volume from 30 to 20. And also I decreased the channel once from 8 to 7. So it is outputting as expected. So yeah, this is the output. Finally, these are my references. I referenced the website that the professor gave in the syllabus, and also other websites on Google to do this assignment. So yeah, thank you for listening to my presentation, and if you have any questions, you can contact me at my email, jshri@umh.edu. So yes, thank you for listening.